Three, two, one. Hi, everybody. My name is Abhijit, and today I'm here with Rodolfo, and we want to chat about measuring the overhead of our SDKs.
Yeah, so we are constantly being asked if I use the Sentry SDK and add performance monitoring to it, what is the memory or CPU overhead that is incurred? We scratch our head and say, okay, we don't know, we haven't measured. So this quarter, we measured and have a better answer for people.
And the idea here is that once we get these numbers, we're a lot more confident talking about our SDKs to our customers internally, and we have a lot better idea on the kind of impact the features that we build are having on customer systems. So now let's cover how we want to approach grabbing this information to understand the overhead of our SDKs.
So what's the overhead of adding Sentry to your application? The answer is, it depends. And it depends on what your application is actually doing to begin with. Depending on what app you're adding Sentry to, the overhead that you're going to see percent-wise is going to be arbitrarily different.
We kind of set a baseline for ourselves to test what adding Sentry would look like. And so in particular, we took a look at a database update and read because we felt that was most realistic to what a customer would like to instrument and measure with Sentry.
So we have a baseline application. Then we add another copy of the same application, this time with Sentry instrumentation, pretty much following the official documentation. That's because we expect customers to start from there. Then we also enable tracing. We have one transaction for every incoming request, and we have a span for every database operation. So this is what it looks like in Sentry.
So you can do all of this manually if you wanted to. Set up a baseline, load test it and measure that, and then set up a Sentry instrumented version of that baseline, load test it and measure that. But it's unwieldy, doesn't scale, and if somebody wanted to test multiple platforms, be able to quickly change different parameters, it was really hard to do. And so in order to make all of that easier, we built out a benchmarking tool, Sentry SDK Benchmark. It's available under our GitHub. Give it a look after this. And it automates all of those processes, setting stuff up, measuring, and collecting data from it. I don't think many people have built anything like this before. And so this is pretty novel. So the benchmark tool creates HTML reports after every single run, kind of representing the different stats that we're measuring, latency, memory, and CPU. The tool also offers you the ability to compare results from multiple runs, so you can get a higher degree of confidence in those actual results.
So the benchmarking tool that we built can handle arbitrary apps. We want now to focus on a specific example and talk about Python Django and talk about the results.
For the trials that we're going to show off, they're 2 minutes duration plus a little warm-up to make sure that they're on a warm start and not cold, on 100 requests per second. Yeah, so we ran our tests on GCP VMs so that we didn't have to worry about, for example, if you run stuff on your personal machine, there's other things going on. You might have Chrome tab running, you might have Slack running. And so this kind of helped us make sure that we were using a machine that was pretty dedicated to whatever the benchmarking load was. Now, this isn't like the most high-powered machine, but again, what we really cared about was this comparison between the baseline app and the one instrumented with Sentry. Here we can see some results for comparing a baseline Django application with one instrumented with Sentry, and we're taking a look at latency by percentile distribution. In terms of overall pattern, they behave kind of similarly. There's just some bounded overhead caused by adding Sentries.
But like when you just look at the raw numbers like this, it's kind of hard to understand, like, is it good or bad? Like, well, what does it even mean, right? That's why we decided to actually compare with something else. And something else we chose is OpenTelemetry.
So taking a deeper look at the comparison between instrumented with Sentry, OpenTelemetry, and the baseline app, we can actually see like up until around the 60th, 70th percentile, OpenTelemetry and Sentry are pretty much neck and neck. It's only by the 90th percentile that we start to perform better than OpenTelemetry. And even then, it's pretty close. And again, this will vary run to run. But in general, through all of like kind of the runs and different parameters that we've tested, we've kind of observed this behavior in the case of our Python SDK.
We don't try to say that, oh yeah, we are absolutely better than OpenTelemetry or anything, but it just shows in perspective that like we add a similar amount of overhead.
And that's pretty much it. We've had, I think, a great time building this out this past quarter. Everything here is available in the GitHub repo, Sentry SDK benchmark. If you're interested in using these results, or if you want to see some specific benchmarks run, please reach out to us on Discuss SDKs or ping me and Rodolfo. We'll be more than happy to help. And thanks.
Thank you.
We don't have an ending slide,
Mm-hmm.
but I don't know what the best way to wrap it up is. Cool. I got this one, I think. 3, 2, 1.